Quantum mechanics. This field of physics deals with the behavior of atomic and subatomic particles. It is meant to describe and account for all the properties in things such as atoms and molecules and the other particles inside them, such as neutrons, protons, and electrons, as well as any other tiny particles like quarks and gluons. In 1801, Thomas Young, an English physicist, performed a double-slit experiment. In this experiment, he put a piece of paper with a tiny hole over a window, then used a thin card to split the light beam that came through. This experiment proved that light is a wave because on the wall behind the card, the two beams of light it made interfered with each other and created fringes. Max Planck, a German physicist, discovered quantum mechanics when he became fascinated by the way hot objects emitted energy in different quantities, depending on their wavelength. In 1900, he finally came up with an answer known as Planck's radiation formula, or E equals hv. E is energy, h is a constant of 6.626 times 10 to the negative 34, and v is the frequency of radiation. This was met with resistance as he renounced previous physics and introduced the concept of quanta of energy. These are small pockets of energy that can only hold a certain amount of energy. He won a Nobel Prize in 1918 for his invention of quantum physics. In 1905, Albert Einstein proposed the quantum theory of light. His theory says that light travels in little bundles of energy known as photons. Many people thought that Einstein was opposed to quantum mechanics because he once said that God does not play dice with the universe. In reality, he did accept that quantum mechanics was indeterministic, meaning it can be unpredictable, and was even the one who discovered that it was. The thing he didn't accept is that indeterminism is fundamental to nature. He also came up with the photoelectric effect, which is the emission of electrons from a material caused by electromagnetic radiation, which he won a Nobel Prize for in 1921. In 1926, an Austrian physicist named Erwin Schrödinger came up with his Schrödinger's equation. This equation is used to predict the behavior of systems that exhibit wave-particle duality. The equation is H, or Hamiltonian, which represents the total energy of the system, the Greek letter psi, which is a wave function which relates the location of an electron at a certain point in space to the amplitude of its wave, equals E, or energy, and psi again. In 1933, he won a Nobel Prize for his contributions to quantum mechanics. In 1927, a German physicist named Werner Heisenberg published his uncertainty principle. In this paper, he expressed that the momentum, or p, and position, or x, of a particle could not be measured simultaneously. Instead, a relationship exists between the indeterminacies, or delta, in the measurement of these variables, where h is Planck's constant that we saw earlier. Heisenberg's conclusion was that causal determinism is impossible as you would need both the position and momentum as initial conditions. Although this became widely accepted by most of the scientific community, two notable physicists known as Schrödinger and Einstein saw the renunciation of causal determinism as physically incomplete. In 1932, Heisenberg won a Nobel Prize for his contributions to quantum physics. In 1973, a British physicist named Stephen Hawking changed his focus to quantum gravity and mechanics. This is because of his meeting with two Soviet scientists named Yakov Borisovich Zeldovich and Alexei Starobinsky. He was fascinated by their work that showed, according to the uncertainty principle, rotating black holes emit particles. After working on trying to figure out black holes for a year, in 1974 his results showed that black holes emit radiation that is now called Hawking radiation. Hawking radiation is when a pair of particles goes near a black hole and one of the particles crosses the event horizon, or edge of the black hole, and the other is left outside and becomes Hawking radiation, forever separating the two particles. Since these two particles had to borrow energy from empty space to appear in the first place, this means that when they would normally break down, they would just give that energy right back. But since the black hole has taken half the energy, it in turn has to repay that energy. This means that black hole slowly loses mass and after an extremely long period of time will die. Although many people believe Hawking deserves a Nobel for his work on black holes, He never received one because his work was theoretical, and these prizes cannot be given after someone has died.